Hi guys, back again. This is just the second part of 2016, question 11. I just broke it into two just to make the files a bit smaller to upload. So we just finished the bit where we did the reagent in excess and we worked out the mass of the excess sulfur. And now we're looking at part 2 and 3 of that same question of 2016, question 11a, which asks us to calculate the total volume in litres of gaseous products formed in the reaction and the mass of solids. So again, you'll see what I've done here. I've written out the equation, okay, like this, with all the information underneath. So I've already worked out from the previous video how many moles of potassium nitrate I started with. I know that's my limiting reagent because sulfur was in excess. And then I also know that I'm looking for the volume of my gaseous products. It says in my equation that nitrogen is a gas and sulfur dioxide isn't a gas. Is a gas, even if I didn't know that. Okay. So the first place we're going to start is to work out how many. Oops, sorry about that. You got an. Oh yeah, a slip there. It just got a glimpse of my fruit bowl. But don't worry, we're back on the chemistry. So what we've got is we've got 0.2 moles of potassium nitrate, and we're trying to work out how many moles in total of nitrogen and sulfur dioxide we produce. So we're going to use our molar ratio to help us do this, and our molar ratio shows us that the ratio is 4 potassium nitrates, gives us 2 moles of nitrogen and 5 moles of sulfur dioxide. So what I'm going to do is work out that if I started with 0.2 moles of potassium nitrate, which I did, how many moles in total of nitrogen would I produce and of sulfur dioxide would I produce? And again, that's easy to do. It's just molar ratio stuff. So I'm going to divide 0.2 by 4 and multiply by 2, and that's going to give me 0.1 moles of nitrogen produced. Okay, now I'm going to work out the amount of moles of sulfur dioxide produced. Again, 0.2 divided by 4, but this time multiplied by 5 because I'm using my 4 to 5 molar ratio, again, given to me in the question. There it is, see that? So I'm multiplying 0.2 divided by 4 and multiplied by 5, and that gives me 0.25 moles. Oh, sorry, I made a shot. 0.25 moles. All right, so now it asks for the total volume of gas. First of all, I need to work out the total moles of gas. So I'm going to add the 2 mole gas products, 0.1 and 0.25, and that gives me 0.35 moles of gas. And I know that 1 mole of gas occupies 22.4 litres. So if I have 0.35 moles of gas, I'm going to multiply 0.35 by 22.4. So I'm going to do that now. Sorry, that's my arm stretching across the calculator. Apologies. I thought I'd worked this one out before, but I haven't. So I'm doing it live, as it were. 7.84 litres. So 7.84 litres is my total volume of gas produced. All right? So the next bit, the last part that it asks, is for the mass of the product. In other words, the mass of the solid of potassium oxide. So again, I'm going to do that now. Okay, I'm looking for the mass of potassium oxide produced, and that's really easy to do because I know already that I started with 0.2 moles of potassium nitrate. Okay, and I can see from my equation that my molar ratio is equal to 4 to 2 in that case. Can you see that? 4 potassium nitrates give me 2 potassium oxides. I know that that's a solid because it says so in the question. It's given to me. So all I have to do, bearing in mind I started with 0.2 moles of potassium nitrate, is work out how many moles of potassium oxide that's going to produce. That's really easy to do. I just divide by 4, multiply by 2, or basically divide it by 2, and I get 0.1 moles of potassium oxide produced. And of course, the question says, what mass is that? Well, earlier on, in the earlier video, we already calculated the molar mass of potassium oxide, didn't we? No, we didn't. We haven't done that yet. So I'm going to do that now. sorry about that. We've got 1 mole of potassium oxide is going to be equal to the atomic mass of potassium, which is 39, multiplied by 2 plus 16, and that gives me 94 grams. Okay, so you see where that came from? That's from my periodic table. 39 times 2 plus 16 gives me 94 grams. So that's what 1 mole, just 1 mole, sorry, of potassium oxide would be. So 0.1 moles of potassium oxide is going to be 0.1 times 94 equals 9.4 grams of potassium oxide produced. That okay? So there you go. That's that question. Like I said, a lot of you have been on to me about moles and moles questions. So I'm going to try and get through another couple of these if I can next week and maybe look at titrations. Hopefully that helps. If you have any particular questions that you're struggling with, you look at the mark scheme, it doesn't make any sense, or you're not sure which answer you should be looking at, let me know and I'll try and do one and upload it if I can, as soon as I can. And I hope that helps. All right, see ya. Bye-bye.